Hey everyone, before we get to the next section 2.6, I wanted to recap the techniques for finding limits that we've seen so far. So from 2.2, 2.3, and 2.5, what are there's different ways to think about a limit in different situations. And I wanted to come back and just, put that all kind of in one easy list um, to kind of try and synthesize that information. So here we go. A lot of this is from 2.2 and 2.3 we saw there, but of course, continuity added more to it, and we took a lot of limits with that. So here is the first, probably the easiest situation, and the situation that we like. If the function is continuous, where we are trying to take our limit at x equals a, then we're just going to plug it into the function. So if your function's ever continuous at a, meaning there's no hole there, there's no jump, there's no vertical asymptote, we can always just plug right in. Okay, we've been saying that from the very beginning of 2.2. But then what happens if there is a hole, if there is a jump, etc.? If there's a hole, and we will know there's a hole because when we attempt to plug in, it would give us 0 over 0. If there's a hole, the vast majority of the time, we're able to simplify. So maybe we can factor, right? Maybe there's a conjugate. We can multiply top and bottom by the conjugate, right? Maybe that's a common denominator, kind of a simplifying. So we simplify first, and our hope is that we're able to cancel out that troublesome piece of the denominator that's making us divide by 0, and then we can plug in. Okay, so we've seen plenty of examples that way. What if there's a jump? Okay, so the jump, we know that the regular two-sided limit would not exist. It would be d and e. That would occur, and sometimes if you're not given a graph, if you're given like a piecewise function, you're going to have to look at the limit on the left and the limit on the right separately, and you're going to have to see that those are not equal to one another. If they're not equal, that left and right sided limit, they both exist, they're just not the same number, then we know there's a jump happening, and our two-sided limit is d and e. I'm not going to get into cases where we're taking the one-sided limits, but we're just kind of thinking two-sided limits here. Okay, we got that. What if there's a vertical asymptote? Okay, so the vertical asymptote is where you might use a graph or a table. And either approach you take, both of them equally valid. I said that before. How do you know it's a vertical asymptote? Some number other than 0. Well, 0 is a number, but I think you know what I mean. Something other than 0 over 0. Like 2 over 0 or negative 1 over 0. Okay, then we know there's a vertical asymptote going on, and we're going to do the graph or the table. Here's the thing. Graphs and tables, a lot of times, I see this every time I teach calculus. It's very natural to do. Graphs and tables, students really like to use graphs, and they err towards tables as well. I think people maybe think tables are maybe an easier way to get to an answer versus like simplifying, something like that. Tables and graphs are only appropriate for vertical asymptotes and in cases where simplifying is just not possible. Okay, those are the only times that graphs and tables are appropriate. Why? Because when you use a graph or a table, you're just taking a good guess or an estimation at the value of that limit. Now, that makes a lot of sense when you're talking about a vertical asymptote because there's only two possibilities. It's either positive infinity or negative infinity. Use that table there or use a graph. But when it comes to the other cases, especially the whole, people try, they like to use these methods here. But the truth is, if this is only a guess, then we really haven't definitively found that limit, say in a whole situation. But if we simplify and plug in, then there's no doubt about it, and we have that limit without question. It's not a guess. Okay. Again, I know if you've been thinking this, I said it in the lecture, but it's very natural to err towards these. Just conceptually, they're easier than simplifying, right? Okay, so here's my note. I really just said this out loud, but um, it deserves repeating. And then I've got another note about exams and quizzes. When given the function as an expression, okay, so when you have the function, written out, x squared plus such and such, you're not told what the graph is. You don't know that. When you're given the function as an expression, using graphs or tables are only a last resort. These are the only way to find limits of vertical asymptotes we talked about. Otherwise, use other means if at all possible. And a lot of times that's going to mean simplifying. Sometimes, though, it may be the case for a jump. Maybe you need to show the left limit and that right limit don't equal each other versus creating a table for the left side and the right side, that sort of thing. Only a last resort if simplifying or whatever is simply not possible. Okay, so what does that mean, when it comes to like exams and quizzes? How will you know if it's not at all possible to say simplify? Because I'm going to tell you. So on an exam or a quiz, I'm going to tell you when to use a graph or a table. I'll say it in the problem. I'll say, evaluate or find this infinite limit using a table, something like that. It's going to tell you specifically to use a graph or to use a table. And I might just choose a table or I might just choose a graph, but I will tell you exactly what I want. If I don't say this, that means there's a better way, and it's one of those other methods. Okay, wow, that took 7 minutes. So okay, I'm glad we could start with this, and I could shoot a quick video. We're going to start 2.6 in the next section, or the next video, I should say.